Bismillahirrahmanirrahim. Once again, I am here with you with a new problem of higher order differential equation with a special kind of function here. In this problem, we have second order differential equation with three functions in form of product or multiplication, algebraic function, exponential function, and trigonometric function. So, as I already explained you that how we can find the complementary function for the differential equation. So the auxiliary equation of the left hand side becomes m squared d from d square minus 4m from 4d plus constant 4 is equal to 0. From this equation, we'll find the root. These are m1 is equal to 2, m2 is equal to 2. These roots are repeated root. Therefore, complementary function becomes yc is equal to c1 plus c2x into exponential mx, that is 2x. Now, for the particular integral from equation number 1, we equate the value of y, that is y is equal to 3x square exponential 2x sine 2x whole divided by d square minus 4d plus 4. Now, we are going to apply the rule, that is because we know that a exponential bx into gx whole divided by f of d can be written as a times exponential bx dot g upon f of d plus b. So here, what is the value of b here? B is the in the power of the exponent, that is 2. So here that would be uh, here I will write f of d plus b. This is the formula, not d plus 2, d plus b. Now we are going to apply this formula. So yp becomes yp is equal to a exponential bx, that is 3 exponential 2x dot x squared sine 2x, and we have to replace what? We have to replace instead of d plus b, that is what? D plus 2 whole square minus 4 d plus 2 plus 4. Now you can apply a plus b formula, that is a square plus 2ab plus b squared, so that the factor becomes 3 exponential 2x into 1 upon d square plus 4d plus 4 minus 4d minus 8 plus 4 into x square sine 2x. So a few terms will be cancelled out. The remaining terms will be 3 exponential 2x times 1 upon d square x square sine 2x. Now you know that 1 upon d square can be written as 1 upon d into 1 upon d. 1 upon d is the integral, and you know that uh, simple d stand for what? Simple d, because we know that simple d is the differential, and d inverse is 1 upon d, that is integral of dx. So we will apply the integral on these function, that is x square into sine 2x. So here we will apply integration by parts formula. So what is integration by part formula? Integration by part formula is integral of u dv is equal to uv minus integral v du. So we will use to find the integral of this function by using integration by parts, and first function we will consider as u, which is u is equal to x square, and the second dv, that is sine 2x dx. Here, when we are going to use the integration by parts formula, we must know one thing, that is a combination. This combination is known as Lie combination, Liate. According to this combination, uh, when we are going to apply the integration by parts formula, we must choose the function according to the arrangement of this seq- uh, sequence, that is Lie. L stand for logarithmic function, I stand for inverse trigonometric function, A is algebraic function, T is the trigonometric, and E is the exponential function. In our problem, we have the combination of exponential and trigonometric, algebraic and trigonometric functions. So algebraic is prior to the exponential function. So we will consider the algebraic function u and dv sine 2x. So this will be differentiate and another function will be integrate. So the differential of the u becomes what? D upon du, du upon dx is equal to 2x, which is du is equal to 2x dx. Similarly, integral of dv will be what? Differential and integral will be cancelled out, and here you will integrate the sine. The integral of sine, when you will integrate the sine, you must need the value of the differential of angle, which is 2x. So 2 is not here, so we will integrate and divide by 2. That is, you know that the integral of sine is minus cos and divided by 2, so that we got the values du is equal to 2x dx and v is equal to minus cos 2x upon 2. Now yp becomes u v minus integral v du. So here u is 3 exponential 2x minus 1 upon d, that is the previous term which already present in the question, as you know. And now this is the previous terms, and now we are going to substitute here u v minus integral v du. 1 upon d will still remain same, so we will multiply these two terms together. So the negative sign we will write earlier, that is minus x square into cos 2x plus minus minus plus integral of cos 2x dot x dx. So again we will apply here integration by parts, and now this function is algebraic function and this is the trigonometric function. So find the integral of this function, we will assume algebraic function as a u and the trigonometric function as dv. So here, according to this definition, this combination, when you will apply again integration by parts formula, so 1 upon d 3 exponential 2x dot 1 upon d minus times x square into cos 2x upon 2 plus x sine 2x upon 2. Uh, this is what, according to the formula which I told you, uv minus integral v du. So here u is what? U is x, and v would be the derivative of this integral of the cos 2, that would be sine 2x upon 2 minus integral times of v du. So when you have u is equal to x, so du is equal to dx. So instead of du you will use dx on, and the v would be sine 2x upon 2. Now finally when you will integrate sine 2x, this will be cos 2x upon 4. 3 exponential 2x into 1 upon d times minus x square cos 2x whole divided by 2 plus x sine 2x upon 2 plus cos 2x divided by 4. Now we will apply the integral on individually on each term, so that we can write it as 3 exponential 2x minus 1 upon 2 integral of this 1 upon d will be transformed into the integral of this term, that is x square cos 2x plus 1 upon 2 integral of this term x sine 2x plus integral of cos 2x. So this is 1 upon 4 times cos 2x. Now here in the first term we have two terms in term of multiplication. X square is the algebraic and cos 2x is trigonometric. Therefore these two terms we will apply again integration by parts. This will be considered as u and this whole factor will be considered as dv. Similarly, in the other terms, here we also apply integration by parts. Algebraic factor becomes u and trigonometrics will be dv. So look at this here, u is equal to x square and dv is equal to cos 2x. U will be differentiate with respect to x. So the differential of u becomes du upon dx and x square will be 2x. So that you will equate du is equal to 2x dx. Similarly, other term dv is equal to cos 2x will be integrated, so that the integral of dv becomes v is equal to an integral of cos will be the sine 2x and division with the derivative of the angle, that is 2. Now for the second factor x into sine 2x, here u is x and dv is sine 2x. U will be differentiate, that is du upon dx is equal to 1, so that du is equal to dx and dv is equal to sine 2x dx. So integrate both sides, v becomes minus cos of 2x divided by 2. Now apply again integration by part, because we know that integral of u dv is equal to uv minus integral v du. So that we will substitute these values according to this integration by parts formula. So look at this now. 3 exponential 2x, in the square bracket we have x square into sine 2x, that is u into v minus integral v du. So we are substituting here the values of uv minus integral times of v du. Similarly plus 1 upon 2 for the second term, uv minus integral v du plus 1 upon 4 and integral of cos is sine 2 divided by 2. So now we will write, little bit simplify, 3 exponential 2x x square into sine 2x divided by 2 minus, and this factor again we have x sine 2x, we again apply here integration by parts, minus x cos 2x will still remain same, plus 1 upon 4 integral cos 2x dx plus 1 upon 8 sine 2x. Now we will integrate remaining two terms, that is x sine 2x and cos 2x. So in the next step, look at this, 3 exponential 2x will still remain as it is, and the first term x square into sine 2x divided by 2 minus times, in the bracket we will apply integration by parts, so we apply here parenthesis first u dv minus v du. So in the bracket we have whole factor obtained from the integration by parts applying on x into sine 2x dx, minus x cos 2x divided by 4 plus 1 upon 4 integral of cos is sine 2x divided by 2 plus 1 upon 8 sine 2x. Now 3 times exponential 2x into the square bracket x square sine 2x divided by 2 plus x multiply, or open the bracket with the negative sign. So minus minus plus x cos 2x minus minus plus plus minus 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 plus 1 upon 2, or cos, integral of cos is sine 2x divided by 2 minus times x cos 2x upon 4 plus 1 upon 4, 1 upon 4 into sine 2x upon 2, that is sine 2x upon 8 plus sine 2x upon 8. For further simplification, 3 exponential 2x into the square bracket we have x squared sine 2x divided by 2 plus x cos 2x divided by 4 plus sine 2x upon 2, and 3 upon 4, taking common 1 upon 4 from the entire term, so that we can write it as 3 upon 4 into exponential 2x, and in the bracket we can write 2x squared sine 2x, this one 2x squared sine 2x plus x cos 2x plus 2 sine x. So we can write now the general solution of the entire differential equation, that is general solution becomes yc is equal to y is equal to yc plus yp. So this is the complementary function and this is the particular integral. So y is equal to c1 plus c2x exponential 2x plus 3 upon 4 exponential 2x times 2x squared sine 2x plus x cos 2x plus 2 sine x. So this was the solution of the differential equation. Now we are taking another problem for more clarification. This problem is associated with again algebraic function and trigonometric function. So once again, uh, we will find the complementary function of the differential equation. So here CF becomes the auxiliary equation. Directly I am writing the auxiliary equation, that is m square minus 2m plus 1 is equal to 0. From this equation, the values of m are m1 is equal to 1 and m2 is equal to 2. Again, roots are repeated, and this is the similar as the previous problem. So uh, the complementary function becomes c1 plus c2x exponential x. Now we are going to find the particular integral, that is from equation number 1, y is equal to x sin x upon d square minus 2d plus 1. And you know that uh, exponential iota theta is equal to cos theta plus iota sin theta. So, and also another formula of the trigonometric, directly we can write it as, when we have trigonometric function, because we know that xn sin bx f of d, that can be written as imaginary part of exponential iota bx 1 upon f of d plus iota b into the polynomial or trigonometric function, or the algebraic function which is, or polynomial which is given into the problem, that is x raised to the power n, or here we have only x, so that we will apply this formula here. So it can be written as yp is equal to imaginary part of exponential iota x upon d plus b. B is what? B is coefficient of power of exponent, that is x. Coefficient of x in the power of exponent, that is iota. So we can write it as d plus b whole square minus 2 d plus 1. So apply a plus b formula. So we can expand it by using the a plus b formula. A square plus 2ab plus b square, that is iota square. Iota square is, because iota square is minus 1, so directly I am writing here minus 1. So open with minus 2, that is minus 2d, and minus 2 iota plus 1 into x times. So in the simplification, we can write it as imaginary part of exponential iota x d square minus 2d iota minus 2d minus 2 iota, and exponential iota x minus 1 upon 2 iota common from the entire factor, and the factor can be written as 1 upon 1 minus d plus iota d minus d square upon 2 iota, because iota is not in the coefficient of d square, so 2 iota will be in the division of the d square. Further, this can be written as imaginary part of exponential iota x into 1 upon 2 iota minus 1 upon 2 iota 1 upon minus 2 iota into 1 minus, and here these two terms will be shifted to the numerator from the denominator, or we will be transformed into the formula. What is the formula? This is the binomial expansion. According to that, 1 minus x power minus 1 becomes 1 plus x square plus x cube, and so on. So we have both the negative sign. So this will be transformed into 1 minus, this is 1, and this entire term is x. 1 minus x power minus 1. So when we will apply this formula, this term will be expanded like 1 plus x square, and so on. So this term, we will only take the power of d from here according to the power of polynomial which is given outside the term, that is x. So x has the linear power. So only when we will expand it, we will only consider the linear power of d from here. So what happened next? Imaginary part of exponential iota x into 1 upon 2 iota 1 plus a plus uh, 1 plus x square, and so on. So this term is the x and x square, because here we have d in the multiple, so that we will get the d square in the next term. Therefore we will neglect the entire rest of all the terms. So we'll take only 1 and 2, first two terms from this expansion, because the linear power exists in second term. So it can be written as uh, x will be multiplied by 1, that will be x, and x will multiply by all the terms which are remaining in the factor, that is 1 plus d time x plus 1 upon 2 iota d square x, and rest of all will be neglected. So these all terms will be vanish. So imaginary part of exponential iota x into 1 upon minus 2 iota x plus 1 upon 1 plus iota is the coefficient of d, and d stands for differential, and we know that differential of x is 1, so that we will write 1 plus iota plus 1 upon 2 iota, and differential of so double derivative of x is 0. So when you will multiply 0 1 upon 2 iota, it becomes 0, entire term will be 0, so that the remaining term, imaginary part of cos exponential iota x can be written as cos x plus iota sin x according to the Euler formula into 1 upon minus 2 iota 1 plus x plus iota. We will multiply and divide by iota because we cannot leave the imaginary number in the denominator, so that we will want to finish this complex number from the denominator, so that we will multiply and divide by the iota, so that we can write it as iota into iota, iota square is minus 1 minus minus plus, so this minus 2 will be plus 2. Now 1 plus cos x plus iota sin x into x plus iota square plus iota divided by 2 iota square is minus 1. This will be minus 1 into plus 1, and this iota square will be minus 1 iota x. Okay. And now we will multiply further this term to the imaginary part of cos x plus iota sin x into xi minus 1 plus iota divided by 2. So image we can write it as 1 upon 2 iota in the beginning. 1 upon 2 iota can be written as in the beginning. So where we were, imaginary part of this, imaginary part of 1 upon minus 2 and minus 2 iota square is minus 1, and this factor which is cos x plus iota sin x will be multiplied to the entire term which are present into the second bracket. So this can be written as iota x cos x plus iota sin x plus iota cos x minus x sin x minus cos x minus sin x. So here we have three terms. In these three terms, three are with iota and three are without iota. So what happened? We will write the real part of the fact of the term into the beginning, that is minus x sin x minus cos x minus sin x, plus iota taking common from the rest of three terms, and the rest of three terms can be written as iota times x cos x minus sin x plus cos x. So uh, what we are looking for, we are looking for the imaginary part from this entire bracket and the imaginary part from entire bracket is this part which is the coefficient of iota. So this term x cos x minus sin x cos plus cos x will be the imaginary part. So our yp becomes 1 upon 2 x cos x minus sin x plus cos x. This is our yp. So the general solution can be written as y is equal to yc plus yp, and complementary solution is c1 plus c2 x into exponential x plus 1 upon 2 x cos x plus cos x minus sin x, and this is our answer. Once again, I would like to discuss to you about the general method for finding the solution, particular solution of a differential equation, because we know that complementary solution is not a problem, because uh, complementary solution can be obtained from the homogeneous part of the function or from the left hand side. So basically the difficult portion of the differential equation is the particular solution. So here, this is the general method to find the particular solution of any problem. If we have 1 upon d minus v g of x, it can be written as exponential bx integral exponential minus bx into gx d of x. So according to this rule, we can solve any problem, any problem by using this formula. So here we will see some example how this formula is applicable to find the solution of differential equation. and we took a problem d2y plus 4y is equal to sec 2x, and we know that the complementary solution can be obtained from the left hand side by taking the auxiliary equation, that is d square y plus 4y. It can be written as m square plus 4 is equal to 0. This is the auxiliary equation. From this auxiliary equation we obtain m square is equal to minus 4. So values of m are 0 plus minus 2 iota. This is the complex number, and we know that in case of complex number, solution becomes c1 cos bx plus c2 sin bx exponential ax. So here a is 0, so it can be written as c1 cos 2x c2 sin 2x exponential 0, that is 1. So C1 cos 2x plus C2 sin 2x is our complementary solution. Now we are going to find the particular integral. Particular integral will obtain by using the same formula as we discussed here as a general method to find the particular integral of any problem. So look at this here from equation number 1, y is equal to sec x divided by d square plus 4. It can be written as particular integral d sec 2x. This is sec 2x, not sec x, sec 2x. Sec 2x divided by d square plus 4 is equal to sec 2x divided by d square minus this plus sign can be written as minus divided by can be break into minus because we want to transform into the complex number, so that we can write minus 2 into 2 iota minus 4 into 2 iota square. Now we will apply here formula of difference of t square. A square minus b square can be written as a minus b and a plus b. Now by breaking LCM into sec x, that is when we will break the LCM of d minus 2 iota d plus 2 iota by using partial fraction. So according to the partial fraction of these two terms will be 1 upon 4 iota, 1 upon d minus 2 iota minus 1 upon d plus 2 iota, and this sec 2x will be right in the end of the square bracket. Now plus 1 upon 4 iota, 1 upon d minus 2 iota sec 2x minus 1 upon 4 iota 1 upon d plus 2 iota into sec 2x. What happened? According to this formula, 1 upon d minus b g of x can be written as exponential bx integral of exponential minus bx g of x. According to this formula, 1 upon 4 iota will remain same. This will be exponential to iota x integral of exponential minus 2 iota x into g of x is sec. This is sec 2x into dx minus 1 upon 4 iota exponential minus 2 iota x and integral of exponential 2 iota x into sec 2x into dx. And we know that sec is equal to what? Sec is equal to 1 upon cos. So exponential 2 iota x divided by 4 iota integral of cos 2x minus iota sin 2x whole divided by cos 2x dx minus exponential minus iota 2x divided by 4 iota integral of cos 2x plus iota sin 2x whole divided by cos 2x dx. So this term cos 2x plus minus iota sin 2x obtained from where? From this exponential iota x is equal to cos x plus iota sin x. So exponential iota x is equal to cos x plus iota sin x, so that this exponential iota 2x can be written as cos 2x minus iota sin 2x. Similarly here exponential plus iota 2x can be written as cos 2x plus iota sin 2x. Now by breaking LCM, this factor can be written as cos 2x upon cos 2x minus iota sin 2x upon cos 2x, that is cos 2x upon cos 2x minus iota sin upon cos is tan 2x into dx minus integral of 2 iota x divided by 4 iota. Similarly, second term cos upon cos. This is cos upon cos and sin upon cos is 10. Now this cos will be cancelled out. That is 1 minus iota tan 2x dx plus exponential 2 iota x upon 4. 1 plus iota tan x tan 2x dx. Now we will integrate. Integral of 1 would be the x minus iota times integral of tan 2x would be the ln cos 2x divided by 2 minus exponential minus 2 iota x divided by 4 will remain as it is, and integral of 1 would be x, and tan 2x becomes minus ln of cos 2x divided by 2. So now we will simplify only to get the answer. Exponential 2 iota x divided by 4 iota x plus iota ln cos 2x divided by 2 minus times minus 2 iota x divided by 4 iota x minus iota ln cos 2x divided by 2. Multiply these terms and open the bracket. So the first term becomes x into exponential 2 iota x divided by 4 iota plus exponential 2 iota x into ln cos 2x divided by 8 minus x exponential minus 2 iota x divided by 4 iota plus exponential 2 iota x into ln cos 2x whole divided by 8. In these terms, we can write similar terms together. So x exponential iota 2x divided by 4 iota will write with x exponential minus 2 iota x whole divided by 4 iota together, and exponential and logarithmic terms we will write together. So here from these two terms we can take the common x upon 4 iota. We can also take the common, and when we will apply the formula of cos theta plus iota sin theta, this will be expand, and here this will be expand with the negative sign. Cos iota exponential iota theta becomes cos theta minus iota sin theta. So the terms which are in the bracket will be obtain expand by using these formulas. So from exponential iota theta, we obtain cos theta plus iota sin theta. From exponential minus iota theta, we obtain cos theta minus iota sin theta. So when we will subtract these two terms, we will get exponential iota sin theta minus exponential minus iota sin theta becomes 2 iota sin theta, and we will when we will add these two terms, we will obtain exponential iota theta plus exponential minus iota theta is equal to 2 cos theta. So for instance, here we will substitute 2 iota sin theta. For instance, exponential 2 iota x plus exponential minus 2 iota x 2 cos 2x. So look at this here, x upon 2, 2 iota sin 2x divided by 2 iota plus ln cos 2x upon 4, 2 cos 2x upon 2. So these two will be cancelled out here. These 2 iota cancel out. The remaining term becomes x into sin 2x whole divided by 2 plus cos 2x into ln cos 2x whole divided by 4. Now the general solution can be written as y is equal to c1 cos 2x plus c2 sin 2x plus x times sin 2x divided by 2 plus cos 2x ln cos 2x upon 4. This is the required solution of the differential equation by using the general method.